You guys are good. None of you guys are being recorded. It's just
So again, like we diagrammed up on the whiteboard yesterday, water is split into two electrons. The electrons are going to go to one of the photosystems, right? It reduces P680. Why is P680 reduced? Remember oil rig, right? Reduction is gain. Gain of what? Gain of electrons, right? Because we're reducing the charge, giving it a more negative charge. So talk yourself through this and figure out why it says it's reduced or it's oxidized, right? So the water gets oxidized because the electrons are leaving. Right on? They're going off to the P680, reducing it. One gets oxidized as the other gets reduced. We get the two hydrogen ions. Why? Because they're pulled off, the electrons are pulled off of the hydrogens. We're in photosystem 2. So we're here.
No, we're not.
We're here.
Yeah.
Yeah. One oxygen atom, which immediately bonds to another oxygen atom. Again, like we said yesterday, oxygen is a diatomic molecule, so it's going to need another oxygen really, really bad. It's gonna really want to be joined up with another oxygen. Did I take attendance? I don't think I took attendance.
No, you did not take attendance.
No,
You were playing music the whole time.
Damn it. Are we good?
No.
Moving on. I watched. Have you guys ever watched Idol's Pity Party?
Yeah.
That clown that sings.
Yeah. That's.
He redid the song "Where Is My Mind" by the Pixies. Oh, excellent. Really? Yeah. It is, dude.
Have you watched it?
Oh yeah.
I love that. Talk about it, dude. That's like.
Oh yeah.
This what? I thought it was Wednesday. No, where you find around here? Bro, these past weeks have been messing up my head.
All right, we okay now? We good? Ready to move on?
No, absolutely. Bonds to another. I got it. Me too. I got it.
All right. This is linear electron flow, where each excited electron will pass from PS2 to PS1 by the ETC. So if we electron transport chain, we're going to abbreviate as ETC. So what we had up here yesterday is linear electron flow. So what I diagrammed up here, right? The electrons went from P680 directly over to P700 and PS1, right? That is linear electron flow. Why would I mention that? Well, because there's a different type of electron flow. There's also cyclic electron flow. We generally only speak of or talk about linear electron flow. If you see any questions on cyclic electron flow, it'll be one or two at the most. It's nothing I would lose sleep over. So the electrons go to the PQ, to the cytochrome, and then to the photocomplex or the photosystem complex, right? Which is PS2 or PS1. I'm sorry. Old school PlayStation. Don't like your beard. That's a mustache. It's above your lip. Somebody needs it. Hey, when we play, when's your next basketball game?
Today.
Today. Or where?
Why?
Because your hair is poking out, dude.
What hairs?
On the back.
Hey! Ah. You're done. You're done for that. You're done. Okay, you know what? I wear a shirt under. Okay? I wear a shirt under my tank top. That's not me. You're looking at the wrong person. I wear suit shirts too.
Everybody good here? Well, I don't want to be seen with her. Everyone stares at me when I look at you, like.
What? Everyone stares at you?
Well, not me, it's her. She feels bad. That's why she doesn't want to. She's got her little.
Directed at me.
I'll see if I can get her out of the house.
Wait, why does she have her eyes?
Why is she playing with scoop? You never know what you're doing.
Oh my gosh, you're so
You
done.
might fall in the ocean and that's fine.
Oh yeah, like he's totally happy that the ice cream melts.
So we don't know why, but for a couple years now, she just, so when we talk about diffusion and stuff, right? How your lungs work, when you breathe in, there's less oxygen in your blood, right? Because the blood has come from your body to pick up carbon dioxide. And what you breathe in, there's now a higher concentration in your lungs. So it diffuses from your lungs into your blood, right? That's the way it is normally. And there's not enough carbon dioxide in your lungs, so it diffuses carbon dioxide from your cells in your lungs.
No, yeah, no,
Versus should be sitting there and like sitting on the couch, you're just doing whatever, and your blood oxygen content is off to like 80%.
Is that why when my first run yesterday, I was going to go to the gym? Like, that's fun.
Sometimes it tastes
Like
metallic, doesn't taste metallic.
Yeah.
Alright, so how do we make, alright. So this will go along with the, diagram we had on the board yesterday, generation of ATP. So we've gone through photosystem 2, we've talked about linear flow, where the hydrogen ions are pulled across, and we're at photosystem 1, right?
No.
The fall of the electrons from photosystem 2 to 1 provides energy to form ATP. When electrons fall from an excited state back down to their ground state, or to a lower state, right? If you think about it, to raise the electron up, right, takes energy, lifts something up, and then you just let go. And as it falls, energy gets dispersed. That dispersed energy is what pulls the hydrogen ions across the membrane against their concentration gradient, right? Remember, we have very few up here and a lot in here.
You put your coffee down, it's stolen, and you're not even going to drink it because you're going to drop it this time. It's strong, it's black coffee.
Hell yeah, it is.
Pure black.
Whoa!
What are we doing? No, what?
So there's a movie, Airplane, that came out in the 70s or early 80s, and it's about the flight of this airplane. It's just super funny, all kinds of dumb jokes all over. And this one, this dude is sitting next to this stick, they're about 8 years old, right? And the steward comes by, and I can't remember, it's either the dude drinking on the dude, they're only like 8, right? And the steward is like, coffee. And the kid's like, oh, no, that's coffee. Cream, sugar? No, I like hot milk.
What?
Right?
That's
It's like a little 8-year-old white boy, dude.
Wait, and the girl was also white?
Yeah.
What? Rose said you're not my type.
So funny, dude. Alright. So the hydrogen ion gradient is a form of potential energy. We need to keep pushing hydrogen ions into the lumen. ATP synthase. Hey, it ends in ASE. What does that mean it is?
Wait, what did you say?
ATP synthase. What is ATP synthase? It ends in ASE. It is a
Reaction.
no.
You said the word for.
Yep, I have said it before. It's an enzyme. Enzymes end in ASE. ASE. We tell you what the enzyme does and what it is. ATP synthase. What does synth mean? Well, to create, to make, right? So ATP synthase. What does that enzyme do? Make ATP, right? We're not trying to trick you, I promise. We're going to tell you exactly what is happening. Again, learn the language of science and it becomes really easy, ladies and gentlemen.
You're done. Why is Einstein on here?
I think that's me on Instagram, aka Einstein. Einstein was my real name when I was a
Why is that a thing?
true story.
It's not a
It was given to me. I don't choose, you don't choose your.
Oh, I remember that time you told me in 9th grade, like, there's this Trump thing, and like some dude was like trying to say stuff to you, and then you were like, no, you made him sound stupid.
That's when there was a picture of me in the newspaper on my
yeah.
motorcycle cut.
Yeah.
And up there in Trump came out. There was a big fight on the beach, and my motorcycle cut when I went to check it out or whatnot. We're just like all over the ground. This whole fight breaks out, dude. Dogs are released on people, pepper spray. It was crazy. The cops released dogs, dude. And all these people were driving black like that. Communist area or whatever. She went out, and the dog ate all this crazy dude. And then they had and these people were trying to hurt her and beat her with her. And they dropped her. So I ran. I picked her up real quick. I think I was just walking on it. But I didn't pick it up because I was a Trump fan. I picked it up because and then we tied it to the back.
Wait, do you have a picture of me?
I'll find it. Alright, so inside photosystem 1. So we've gone from photosystem 2 with P680 to photosystem 1. Here's the electron. Came from photosystem 2 down to the PQ, down to the cytochrome, down to PC. Light energy is hitting these chlorophylls to P700, right? The energy hits those, sends an electron up. So the electron that came from here is going to replace the electrons that go up there in linear electron flow. Oops. So light energy excites the electrons in the P700 chlorophyll molecules, becomes P700 plus. Why does it become P700 plus? Well, the same reason that P680 became P680 plus. Once the electron leaves, it has a more positive charge.
Bless you.
2 days ago. Are we good now? Alright. So, the electron comes up here to the primary acceptor. Electrons go down the second transport chain. FD, you don't need to know what that is. The electrons go down to NADP plus reductase. NADP plus reductase. What do you suppose that is?
Oh, when it reduces.
Reduces what? It's right there.
What?
NADP plus reductase. What is that?
When it
It is
reduces
an
the NADP.
enzyme, because it ends in ASE, and it does what?
Reduces the enzyme.
Not the.
It reduces the NADP.
It reduces NADP plus.
Plus, yeah, I got the plus.
Wait, isn't there an NADPH, right?
Okay, and it becomes NADP plus is going to become NADPH. Yes, absolutely. NADP plus reductase catalyzes the transfer of electrons from FD to NADP plus. If I can give you a hint, you're going to see letters like this again in cellular respiration. You're going to see NAD plus and NADH in cellular respiration. How are you going to remember which one is in photosynthesis and which one is in cellular respiration?
Wait, what'd you say?
You're going to see NAD plus and NADH in cellular respiration. You're going to see NADP plus and NADPH in photosynthesis. How are you going to remember which one goes where?
The plus is first.
Uh-huh.
Right.
Huh? No. No. The one with the P in it is in photosynthesis.
Oh, bro.
NADPH, NADH. The one with the P is for photosynthesis. Don't confuse them. Right? You're going to see NADH or NAD plus reductase in cellular respiration. What I'm telling you is, don't think it's the same thing. It's different.
Wait, so NADPH is just the hydrogen, right?
Is with the hydrogen added, yes.
Well, two NADP.
So the NADP plus, remember, reduction is gain. We're going to reduce by gaining electrons onto the NADP plus and adding that hydrogen ion.
Where does the hydrogen ion come from?
The hydrogen ion comes out of the ATP synthase. So hydrogen ions, when they fall through ATP synthase, create ATP, and that hydrogen ion is now there, and it's going to be attracted to this because of the charge. Right on? And that's what forms NADPH. Why? Because I don't want to do, plan on doing, so I gotta figure out what I'm gonna do for water. I'm planning those classes on teaching.
What? Why don't you just plan out the day before?
I did have it planned, now I don't want to do it.
Why? What? You just make it, you just complicated for yourself.
I do, I should just follow the plan, but I don't. I am.
What are they learning about?
Evolution.
Bruh. Just have them go outside and take pictures of birds.
All right. So light reactions, putting it all together here. We go splitting water, electrons come up to PS2, light energy excites chlorophyll in PS2, boosting this electron. As the electron falls down the energy gradient, it pulls hydrogen ions across, right? It gets over here, light energy excites everything here. This electron vacates, this electron takes its place, this electron as it vacates, goes up here, converts NADP plus and a hydrogen into NADPH. All the while these hydrogens are coming across, they go through ATP synthase. See how this has this little arrow here? Think of it like a little turbine, right? That hydrogen goes through and it hits like a fan blade. And as it turns, that's what makes or joins ADP and the phosphate to make ADP and the P into ATP. Now we got ADP. So ADP and the phosphate into ATP.
So because the phosphate
Yes. Adenosine triphosphate, right?
and the hydrogen.
No, the hydrogen doesn't do anything to the ATP or the ADP, right? The hydrogen, you can see, just flows through, right?
So it's just
It's not doing
releasing
anything.
the hydrogen.
It flows through, so you have hydrogen ions out here that go to the NADPH or NADP plus to make NADPH. This motion of this little turbine, this enzyme, connects the ADP and the phosphate making ATP. Cool? if you think about this, this is why you have to keep sending hydrogens out in here. Why? Because they're coming through here, being joined up here, so we're taking hydrogens away from here and here, so we have to keep pumping them across. Any break in that chain, and it stops. If you stop NADPH from donating its electrons in the Calvin cycle, you will shut this down. Why? Because if all the NADP plus is used up and it's holding on to electrons and hydrogens, and there's no more to accept electrons and hydrogens, there's nowhere for this stuff to go, which means the whole system shuts down. We have to be able to recycle NADPH, or NADP plus from NADPH. So, inputs in the light reaction. What are the inputs? Water, ADP. If you want, next to ADP, you can also put the inorganic phosphate and NADP plus. Outputs, oxygen, ATP, and NADPH. Oxygen is a waste product. ATP and NADPH are carrying the energy that we need to build glucose in the Calvin cycle, the light-independent reactions.
Is that a joke?
Oh, you need to get.
You know, it's like my sister wears a cross and she doesn't believe in God. Yeah.
Did I tell you this, that dyslexic atheists don't believe in dogs?
And dogs?
Dyslexic
Oh, you're a dog.
atheists.
Bro, you're a
Dyslexic
dog.
atheists don't believe in dogs. I know. So I keep asking for Christmas and I never get it. There's a tiny little drum set that I want to put on my desk, so after I tell jokes I go no big deal. It'd be so funny. I would find a way to rig it into a necklace so I could walk around, still teeth. Amazing. Alright. Light reactions. So, convert solar energy into the chemical energy. The chemical energy is the ATP and the NADPH. Oh yeah, I said that. Water is split by an enzyme, where we get oxygen as a waste product, electrons pulled off of the hydrogens to give us electrons to use in the electron transport chain, and hydrogen ions used to go through ATP synthase to generate the ATP. Oh yeah, I just said that. So the light that is absorbed by the chlorophyll, remember chlorophyll is a pigment. Pigments are able to absorb light, right? That drives the transfer of the electrons and hydrogen ions from water to an electron acceptor called NADP+. So again, you don't need this word for word. How many times have I gone through this entire process?
Okay, but it literally tells us to write it word for word.
Oh, yeah, well, no, I was thinking this part was
Okay.
blank.
Yeah.
I was thinking it was blank. You just gotta fill in the blanks. I thought it was just
You're
like
good.
a paragraph to write. It's not.
Well,
Okay.
it is, but.
Are you trying to stick it up the ceiling?
Were you in my class when I had like 20 of these in my cylinder? Were you in my class when I had like 20 of these?
Yeah. Remember one time I asked you for a pencil? I asked you for a pencil and then you walked up. Why do you
Throw- What? I think it was like 3 years ago. I walked into, what's her name? Frank. It was like in between passing periods. And I just like dipped into Frank's room real quick. Stuck into the ceiling. Somebody in that class got blamed, dude. Yes. No.
That's what I mean.
Usually with a small child.
Usually when you say
Yeah, NADP plus is reduced to NADPH.
What the hell?
If you couldn't fill that in. Ooh, what does the next sentence say? Generates ATP by
ADP?
phosphorylating ADP and, well, it phosphorylates the ADP with the inorganic phosphate, right on.
Sorry. Oh, the phosphate.
Good job.
Oh, whoa, I'm learning.
Ooh, holy smokes, got a diagram of that, do you? Mm.
it's like 3 pages of like, oh.
Alright, so, here you go. What, Calvin cycle? So, we're gonna move on to the Calvin cycle. And you will get to, do those pages we're skipping right now for your homework. To review, like-dependent like-dependent reactions. What does that do? Tomorrow, dude. Let's go. Alright, Calvin cycle. Basically, we've got water and the oxygen and our light reactions. Now we're going to use carbon dioxide and get the sugar, right, from our basic formula. What else do we have going in there? ATP, NADPH. What's coming out? NADP plus, ADP, and an inorganic phosphate.
No, it broke like 4 times. I know what ATP does to be ATP. You mean what ATP does to be ATP? Oh yeah. What? How do you do that so easily?
So, Calvin cycle, cyclic electron flow. Why? Because it's a cycle. It goes round and round.
Wait, hold on. Where is this? Oh, stop.
Yep, that's your homework.
Oh, that's good. Thanks for doing that.
Yeah. So it uses ATP and ADH to reduce carbon dioxide to sugar, G3P. We're going to use 2 G3Ps, and we'll get to that. Reduce, what does that mean? The carbon dioxide is going to be reduced. What does that mean? What's going to join the carbon dioxide? Hydrogens. Absolutely, right? Because the hydrogens are carrying the electrons that are doing the reducing. Cool, reduction is gain. They have to gain something. Carbon dioxide has to gain. Again, remember what I said, we follow we follow 2 things in cellular respiration and in photosynthesis. We follow carbons and we follow hydrogens. That tells us everything. For a net synthesis of 1 G3P molecule, the cycle must take place 3 times. And if we go through it 1 time, it'll show you why we need 3 times. Because we're trying to take CO2 and make C6, H12O6. Right? That's glucose. Well, we don't have that. We've got CO2. Right? It takes 6 CO2s to make C6. Right? It'll make sense, dude. Yeah. All you gotta do is follow along. Alright, here we go. This is the Calvin cycle. You need to know this. Every single step. I'm just kidding, dude. No. you do not need to know the intermediate products. The important parts of the Calvin cycle are going to be right up here, Rubisco, right down here, and right over here. And again, knowing where NADPH and ATP go in and out so that you can count the numbers of ATPs and NADPHs. There are 3 phases. The first, carbon fixation. What does fixation mean? If we say something is fixed in science, what do we mean?
Change.
It kind of almost changed, but how?
It's there's a word.
It's made usable. Yes, absolutely.
Usable?
Yes, fixation means it's made usable. As it stands, that carbon dioxide cannot be used. Right? It isn't in a form that we can do anything with. We have to make it usable. It has to be fixed.
Oh.
Cool?
Makes sense. Wait.
The second phase is reduction. Reduction. What do you suppose we're going to do? We're going to add hydrogens.
In order to reduce the carbon.
Yep, absolutely. And then the regeneration of RUBP. If we do not regenerate RUBP, we are in a hurt locker. That means we can no longer fix carbon for another cycle. Gotta be able to fix or regenerate RUBP. So, part 1. Fixation of carbon. You ready? Carbon dioxide is incorporated into the Calvin cycle one at a time. So you've got this little cycle hanging out. Where's this taking place again?
Wait, this one.
Where are the light independent reactions taking place?
Wait, we're writing this down.
Where is this taking place? Where in the thylakoid? The lumen is inside the thylakoid. Oh wait, yeah, not thylakoid.
Wait, what?
So light dependent reactions take place in the thylakoid. Where do light independent reactions take place?
In the stroma?
In the stroma. Yeah, absolutely. Just outside the thylakoid, right? So when we look at this picture here, remember this is the thylakoid membrane, right? The NADPH and the ATP are outside the thylakoid. Why? Because that's the stroma. That's where they need to be used for light independent reactions. All right, each carbon dioxide attaches to a molecule of RUBP. This reaction is catalyzed by Rubisco. Not to be confused with Nabisco. Ding. Nabisco is a company that makes crackers. Come on. It's got a little red triangle, says Nabisco. Ding. Biscotti? What? No. Nabisco. Look it up. Somebody look up Nabisco. You're killing me.
Let's see when this was created. That makes sense.
I do still do crackers.
That's pretty crazy. I didn't know you
That's
had
great.
to.
Oh, wait, no, I know Nabisco.
Jesus.
Oh, yeah.
Yeah, Nabisco.
Like
Look, they make
the
Chips
right?
Ahoy, right? Yeah. Nutter Butters, Chips Ahoy. Come on, dude. What you guys know
What
anything
the
about?
heck? I thought they are like, I thought Oreo and them were like their own company.
No.
Like Apple and Android, like, that's what I thought.
Once it's catalyzed, it forms 3-phosphoglycerate.
There's no more base.
No.
Oh yeah.
There's things in there I would question, but I mean, it's not bad.
Oh, yeah.
Just doesn't go in depth, but if somebody could help me make videos like that, I would be like, dude, all right, I need to say this and this and this and this, and then you guys can generate it. Like if you're tech savvy and whatnot, not me, what? Okay, get out. Now, yourself. See, that's the kind of power I have.
I wanna donate blood. I wanna save lives.
I gotta change, every time I go to the doctor, all he does is draw blood out of me, I gotta find a new doctor. Do not go to Dr. Acula.
You get like a free gift card.
Does nobody get that? Dr. Acula draws
My
blood.
life is worth it.
Dracula, come on, dude, stick with me, people. Moving fast.
Oh my gosh, Ellie, I got that on video. When you said to me so much.
I'm not so cheap.
It's not posted on YouTube.
Right?
Your ass.
Cancel.
You said worse.
I'm gonna be on the pretty good. I'm gonna be on the show about how my feelings were hurt.
Well, you said it right. You're gonna be
Yeah.
Yeah, you're awesome. You also said your wife is obese.
Or put a cake in a hole, sure, but. Alright, phase 2, the reduction. Each molecule of 3-phosphoglycerate is phosphorylated by ATP. That's on video.
What?
Wait, so
At least they don't say what wrong is. Here again. So after the ATP interacts, it becomes 1,3-biphosphoglycerate. Again, you don't need to know all of these intermediates, ladies and gentlemen. You are not going to see this on an assessment. I'm not going to be like, yes. Yeah. I'm not going to be like, oh, after it's reduced, what does it become? There's no need. There's no need for it. You can always look that up if you need to know it for something. I'm not going to ask you.
Mr. Wright, do you know anyone that has a free second period?
I mean, I don't charge for second period. Then we use 6
You're
NADPH.
canceled. You're literally canceled.
They donate the electrons to the 1,3-biphosphoglycerate, and that reduces the 1,3-biphosphoglycerate to G3P. Ugh. I mean, that is rough, dude.
I would eat it, but I don't know what that pick it.
Even in college, you shouldn't need to know the intermediates in the Calvin cycle or the Krebs/citric acid cycle, right? I have never had a class where I needed to know all of the intermediates. So don't stress yourself out about these mayonnaise words.
What do you mean free second period?
Like to record you, cause I'm gonna mic you up.
What else do you want?
No, like someone else to record
You're doing one
you.
is chocolate.
Like someone that has a 3-second delay to record you talking.
You said you do.
Oh.
Te pregunté y tú dices que es una amigas.
Well, she's a TA.
Okay, but she's only like she can.
Khan Academy?
That's not far.
Oh, she's gonna pass out.
What do you mean? This guy is like the oldest entertainer.
Mr. Dean? Yes, I do know him. I work with him. No. Like work to make up, yeah.
He put it on a video that like.
So, in this process,
That one scoop's tile.
6 molecules of G3P get formed, but only 1 is counted as a net gain. When we follow carbon and stuff around, that will make sense. So we formed 6, but only 1 is a net gain. The other 5 are used to regenerate RUBP. Remember what I said earlier, RUBP is not regenerated, it shuts everything down because we can't then fix carbon dioxide. If we can't fix carbon dioxide, we can't use the ATPs and NADPHs. If we can't use the ATPs and NADPHs, we'll run out of ADP and NADP+, which will shut down the light-dependent cycle. So we have to be able to regenerate RUBP so that this is a cycle. Or it would just be a linear thing and there's no net gain of energy. Yeah, I did not take a test because I don't remember.
Hey.
I got that.
We couldn't use it. You think that's too heavy?
Vanilla. And cotton candy.
Alright, the regeneration of RUBP. 5 G3P molecules. 5 G3P molecules
After cotton candy.
are used to regenerate the RUBP. 3 ATPs used for the regeneration. So if we look at all of this, what we will do is understand how much NADPH and ATP is used to generate a glucose, and then when we go to cellular respiration, figure out how much ATP we get from the glucose, and we'll see if this is an energy efficient process or not. Right? Do we gain any energy? The cycle is now ready to take in another carbon dioxide. And it repeats.
Wait, go back. Oh.
I am. So when you look at this next diagram, this part is going to be important to understand why all of this happens this way. The next diagram that you have pulls everything together, and it starts right here. Right? We have our ribulose, biphosphate, rubisco. Here is, so how many carbons are here? Ladies and gentlemen, this is what you have to do now, is you have to trace carbons. I understand, there are 5 carbons here, right? Yes, no? You guys understand that from chemistry, right? The black indicates it's a carbon, correct?
Yes.
This is on your diagram right there. You've got a 5 carbon molecule, right? Don't pay attention to the number 6 underneath on your molecule. So you have a 5 carbon molecule. If you add a carbon dioxide to that, how many carbons do you have? 6, right? That gets broken into 2 3 carbon molecules. After that goes into the 3 carbon molecules, one of them goes out here. You have a 3 carbon molecule. Can you regenerate RUBP? No. Because RUBP has 5 carbons in it, correct? When we start tomorrow, this is going to be goofy and difficult. We are going to draw out why, because we only have like how much time?
2 minutes.
Oh, we have 2 minutes?
What was your time?
So we're going to draw it out so that this diagram makes sense. Why they have 6 CO2, 6 H2O, and all that stuff in there. Right on?
You saving those. Come on. I'm kidding.